Space is incomprehensibly vast. A trip to even our very closest planetary neighbors would take months or even years. From here to the edge of the solar system is a journey of several decades across nearly 20 billion miles. The next nearest star is more than 23 trillion miles beyond that. Our Sun is only one star among as many as 400 billion in the Milky Way galaxy. The Milky Way is one of 2 trillion galaxies in the observable universe. There are probably more than 100,000 as many stars in the universe than there are grains of sand in all the beaches on Earth. For now, traversing the immense distances between stars and galaxies will have to remain within the realm of science fiction. But with such a vast, boundless cosmos to explore, the possibilities are infinite. Some of the things astronomers have already discovered might even seem too fantastic for science fiction. We've only begun to scratch the surface of what exists out there in the void of the universe. In the words of the poet Lord Byron, "'Tis strange, but true, for truth is always strange, stranger than fiction." This is matter, and these are some of the most bizarre space phenomena ever discovered. Fast radio bursts. In 2007, astronomers at West Virginia University were sifting through archival data from the Parkes Radio Observatory in Australia. These astronomers uncovered an anomaly, a very short, very powerful burst of energy, emanating from the direction of a small Magellanic Cloud. The burst was very faint and lasted only 5 milliseconds, but further analysis of the burst indicates that it could only have come from somewhere outside of our galaxy, possibly as far away as 3 billion light-years. The burst never repeated, implying it came from a singular event. Over the years, many more of these strange pulses have been observed, with nearly all of them originating far beyond the Milky Way. These phenomena have become known as fast radio bursts, or FRBs. Despite there not being more than 500 FRB detections to date, their origins are not entirely understood. Not every FRB is the same either. Some bursts only happen once, giving off a brief, powerful flash of energy, and then go dark forever. But some bursts seem to repeat irregularly, with no discernible pattern. To add to the mystery, the radio waves that we detect from many FRBs is polarized, which means that they must originate within an intense magnetic field. There are several theories of fast radio burst sources. It is possible they are connected to gamma ray bursts, which occur when a supermassive star explodes and collapses to form a black hole or a neutron star. Another theory is that they occur during collisions between black holes or neutron stars. Some more outlandish theories include the explosive decay of theoretical dark matter particles or cosmic strings interacting with the hot, dense plasma from the start of the universe. Of course, some have hypothesized that FRBs are evidence of extraterrestrial technology, and we are picking up traces of some distant alien communications. As enticing as this possibility may seem, there is little evidence to suggest that these pulses are not naturally occurring. In 2020, an FRB was detected in the vicinity of a celestial object called a magnetar. A magnetar is a type of neutron star that generates an extremely powerful magnetic field, trillions of times stronger than the Earth's magnetic field. The detection of fast radio bursts emanating from a magnetar seem to confirm that magnetars are at least one source of these strange pulses. But we still don't know what exactly causes these FRBs to happen. What mechanism is releasing these intense, momentary flashes of energy? Why do they sometimes occur only once and sometimes repeat? What other astronomical objects might be responsible? Is it something we already know? Or is it perhaps something we are yet to discover? Dark matter galaxy. Dark matter is one of the biggest unresolved mysteries in science today. It makes up an estimated 85% of all matter in the entire universe, and yet we cannot see it. Whatever it is practically impossible to detect, since it doesn't seem to interact with visible matter except through gravity. Gravity is the glue that holds a galaxy together, but when astronomers look at the number of stars in a given galaxy, it appears that there aren't enough to produce the gravity needed to keep the galaxies from falling apart, so there must be another component that we can't see. That is where dark matter comes in. Dark matter fills in the space within a galaxy, adding enough mass and generating enough gravity to keep the galaxy intact. In 2016, astronomers using the Keck Observatory in Hawaii were trying to get a closer look at the galaxy around 330 million light-years away, called Dragonfly 44. This distant galaxy appears incredibly diffuse, emitting only 1% of the total light of the Milky Way, meaning it must have only a small fraction of the number of stars. However, Dragonfly 44 was observed to be much heavier than expected, only a little less massive than our own galaxy. Dragonfly 44 presented a paradox. It appears very light and diffuse, and yet very heavy and dense at the same time. The explanation is that Dragonfly 44 is a dark galaxy, one that is made up of almost entirely dark matter. Studies of stars' velocities within the galaxy show that dark matter may comprise of up to 98% of the galaxy's total mass. Just exactly how these dark galaxies came to be, or even how many of them might be hiding out there in the universe, remains unknown. Hormaya. Our next bizarre discovery was not found in some distant galaxy, but in our own cosmic backyard. From the time of its discovery in 1930 up until 2006, Pluto was considered the 9th planet in our solar system. But the discovery of several more Pluto-sized objects in the outer edges of the solar system led the International Astronomical Union to create a new class of celestial object, the dwarf planet. So far, Pluto and 4 other objects have been classified as dwarf planets. Most of them are lonely, icy bodies out beyond the orbit of Neptune. But the dwarf planet Hormaya is inarguably the strangest one of them all. Unlike the rest of the dwarf planets, Hormaya is not spherical. It is significantly flattened, so that it more closely resembles an egg than a round ball. Hormaya's odd shape comes from its unexpectedly rapid rotation. It spins on its axis once every 3.9 hours. Such a fast spin causes the relatively soft ice on the dwarf planet's interior to deform and flatten out. But its unique shape is not all that makes Hormaya an oddity. In 2017, astronomers observed Hormaya passing in front of a distant star, an astronomical event known as occultation. The astronomers noticed something unusual in the data. The light from the star dimmed slightly just before and right after Hormaya moved itself in front of it. After an extensive analysis, they were able to determine that Hormaya actually has a dusty ring, although it is much thinner and fainter than Saturn's famous rings, and is only one of very few non-gas planet objects known to possess a ring. The prevailing theory to explain Hormaya's many bizarre features is that the result of a massive collision between 2 objects in the violent, chaotic formation of the solar system. This collision can explain why Hormaya spins so fast. Its 2 moons, Namaka and Hyaka, along with Hormaya's rings, are possibly leftover debris from the impact. There's ongoing work to find and identify objects at the edge of the solar system that may be a part of the so-called Hormaya family, objects that were born out of the same collision. Finding these collisional family members might offer us some more insight into Hormaya's formation and the conditions that exist in the very early days of our solar system. Nuclear Pasture. Neutron stars are the collapsed ultra-dense cores of dead stars left behind in the wake of a supernova explosion. Not every star will create a neutron star. A star must be at least 10 to 25 times the mass of our own sun in order to produce a supernova at the end of its life. When a supermassive star dies, the supernova releases an unthinkable amount of energy. A single supernova can briefly outshine all the light from all the stars in an entire galaxy combined. This incomparable release of energy causes the remnant cores to collapse inwards, packing the material so tightly that the density approaches the maximum limit allowed by the laws of physics. A typical neutron star might have 1 to 2 times the mass of the Sun crammed into a sphere 20 kilometers wide. These stellar remnants are so dense that a single tablespoon of neutron star stuff would weigh more than 1 billion tons on the surface of Earth. This incredible density generates a phenomenally strong gravitational pull. The escape velocity from near surface of a neutron star is more than half the speed of light. Neutron stars are strange enough, but even stranger is what goes on inside, below the surface of a neutron star. The density and pressure only increase. The electric repulsive force and nuclear attractive force between the subatomic particles start to compete, and the protons and neutrons settle into strange patterns, forming a new type of exotic matter. These patterns will change through several different phases the deeper you go into the neutron star's core. Because of its appearance during these phases, this exotic matter has been dubbed nuclear pasture. For a typical neutron star, the nuclear pasture layer must be as much as 400 feet thick and have a combined mass of 3,000 Earths. The Random Transitor. The Kepler Space Telescope was launched in 2009 and operated in space for nearly 10 years until 2018. Kepler's primary mission was to search the sky for signs of extrasolar planets, planets in orbit around stars outside of our solar system. Kepler was designed to detect this telltale dip in brightness, which allows astronomers to estimate how big the planet is and size and shape of its orbit. Astronomers prefer to wait for a single planet to transit multiple times in order to confirm their findings and rule out any false positives. Typically, only one transiting planet is ever observed in the given star system, sometimes two or more if we're lucky. However, a team of astronomers were analyzing archival Kepler data in 2019 and discovered something truly baffling: a staggering 28 transits in an 87-day period. Even more unusual is that these transits show virtually no signs of repetition. Normally, a pattern is clearly visible every time the same planet transits the star, but this is not the case with this system. There is no discernible regularity in transit times, depths, or durations. The team wrote their publications of their findings that the transit arrival times could just as well have been produced by a random number generator. The team triple-checked the data and have confirmed that these 28 transits are indeed real and not the result of some error or misinterpretation of the data. Some theories have been put forth to try and explain what could have caused these seemingly random transits: an unusual number of planets in the system, constantly perturbing each other's orbits and causing huge variations in transit times, or a planet might be in the process of breaking apart and the debris was detected transiting the star. Other theories include large, dust-producing asteroids or short-lived instabilities in the atmosphere of the parent star. Again, there are also some hypotheses that these transits are evidence of an extraterrestrial civilization. Dr. Andrew Vanderberg, one of the discoverers of the Random Transitor, said, "In astronomy, we have a long history of not understanding something, thinking it's aliens and later finding out it's something else. The odds are pretty good that it's going to be another of those." There is no shortage of theories, but so far none of them have been able to adequately explain what has caused these transits. For now, the true nature of the solar system remains a mystery. Thank you for watching Matter. Make sure to like this video and subscribe to the channel to learn even more about our strange universe. Leave a comment below on which of these discoveries you think is most bizarre.